Hi, and welcome at Keysight Center of Expertise in Böblingen, Germany. My name is Adrien Louchet. I am Solution Manager for the Datacom industry. And today I'm pleased to introduce our first-to-market compliance test solution for interface running at 100 gigabit per second and per lane. This is the underlying technology for the next generation data center. Current electrical interface in a data center are running at 50 gigabit per second using the 25 gigabaud PAM4 signaling. Moving to 100 gigabit per second and 53 gigabaud PAM4 will enable next generation optical transceiver like this one, 800G transceivers, as well as 51.2 terabit switches. This will allow the data center operators to first keep pace with the ever increasing demand for bandwidth and switching capacity, and at the same time reduce the cost and the power consumption of the transported bit. This move to higher baud rates brings challenges for the component, chip, and channel designers. Besides excess loss at higher frequency, reflections are causing severe degradation to the signal. And for instance, complex equalizers have to be used at the receiver side to reopen the eye. The conformance test procedures are also getting more complex. Currently, the IEEE 802.3CK as well as the OFCI 5.0 working group are working on these procedures. New aspects include the emulation of the receiver noise, the usage of a two-stage gain CTLE combined with a 4 taps DFE as a reference equalizer, and finally the use of the vertical eye closure penalty metric during the stress input test calibration procedure. In order to help the engineering teams to move forward, Keysight recently released the industry-first compliance test solution for 100G interface covering both TX and RX test. This consists of a M8040 BERT and of a N1060 sampling scope. This could be replaced by an Infinium UXR real-time oscilloscope as well. This solution supports over 140 different measurements, automate the calibration and the test, and also enable the user to test beyond the standard and carry out root cause analysis. Let's first have a look at the transmitter test. Today's configuration consists of an N1060A module. It is a precision waveform analyzer with 2 channels and 85 GHz bandwidth. It also includes a clock and data recovery that can accommodate signal up to 64 gigabaud even after transmission over a long channel. Combined with the new Flex DCA software, it can fully support the IEEE 802.3CK measurement, such as the new CTLE definition with 2 gain stages, a 4 tap DFE with pulse response optimization, and it can also add a fixed amount of noise to emulate the receiver intrinsic noise. In addition, the N1091 CKCA electrical transmitter test application offers a comprehensive coverage of IEEE transmitter test, and it supports, for instance, chip-to-module, chip-to-chip, copper, and backplane interfaces. It supports the automation of over 120 transmitter measurements. It provides an auto-tune utility that finds the optimal CTLE and DFE setting for specific transmitter and channel combination. It also offers utility tests to speed up the development and validation of your transmitter design. Let's now have a look at the receiver test part of the solution. It includes a M8040 BERT platform combined with an oscilloscope. The oscilloscope is used to calibrate the aggressor lane and the stress lane. The M8040 BERT includes a 2-channel pattern generator operating at up to 64 gigabaud PAM4 and offering functionality such as jitter injection and 5-tap DN phases. It also includes an M8046A error detector with internal clock recovery and an M8054 interference source to to generate sinusoidal interference and random noise up to 32 GHz. Both types of receiver test methodologies can be addressed with this solution. The stress-high method, where the victim lane is calibrated after the channel toward the worst-case signal allowed by the standard. This method is used for testing chip-to-module interfaces. But also the channel operating margin method can be supported with this solution. It is mostly used for chip-to-chip interface. In this approach, a specific amount of random noise, which depends on the transmitter and channel characteristic, is injected in front of the receiver to reach an equivalent signal-to-noise ratio the DUT is expected to accommodate for. Both approaches rely on complex characterization and test procedures, which can take hours to carry out, even for experienced engineers. For this reason, Keysight developed the M8091 CKPA pre-compliance receiver test application, which automates all steps required for the stress signal calibration and test, offering unprecedented measurement accuracy and repeatability. Besides these key functionalities, the M89 CKPA application offers features such as retrieving previous calibration setting and results, automated transmitter deink phases optimization, and seamless integration with Keysight Analytics solution. I hope you enjoyed this brief overview of our compliance test solution for 100G interface. If you have questions, get back to your Keysight representative or go to www.keysight.com/find/800G. Thank you.